There are about a dozen different ways this could actually be the end. Not the dramatic, movie poster kind of end. Most of those are the ones we should worry about least. The real ones are quieter. One of them you already lived through, whether you realized it counted. Another one already grazed us within the last 15 years, and almost nobody noticed. So here's the question this video actually answers. Of every scenario that's ever been called a doomsday event, which ones are real threats, and which ones are just good movies? We're going through every major doomsday scenario that scientists and risk researchers actually take seriously enough to study. Not every apocalypse a movie has ever invented. By the end, you'll know exactly which risks deserve your attention, which ones don't, and why the boring ones are the dangerous ones. Start with the one everyone already has a mental picture of, because it already happened. 66 million years ago, a rock roughly the size of a city hit what's now Mexico, and 3/4 of all species on Earth didn't survive what came after. Here's the part most people miss. The impact itself wasn't the main killer. It was the mechanism that followed. Vaporized rock and sulfur blasted into the stratosphere, blocked sunlight for months to years, and shut down photosynthesis at the bottom of the food chain. Everything above it starved in sequence. Could it happen again? Physically, yes. Space doesn't run out of rocks. But here's the reassuring part. This is the one doomsday scenario humanity is actually good at defending against. We've now tracked more than 90% of asteroids over a kilometer wide, roughly the size that could cause that kind of global damage. And in 2022, a spacecraft called DART slammed into a small asteroid and measurably changed its orbit, proof that deflection isn't science fiction anymore. This is the rare existential risk we've already started solving. Underneath Yellowstone sits a chamber of partially molten rock big enough to bury the state of Rhode Island a mile deep. It's erupted at that scale 3 times in the last 2.1 million years, with roughly 600,000 to 800,000 years between eruptions. That gap isn't a countdown, though. The spacing between those 3 eruptions wasn't even, and geologists are clear that treating the average as a schedule is bad math. Yellowstone isn't overdue any more than a coin is overdue for tails after landing on heads twice. The mechanism is almost identical to an asteroid strike, just triggered from below instead of above. A supervolcanic eruption throws enormous volumes of ash and sulfur dioxide into the stratosphere, and the planet's temperature can drop for years. The 1815 Tambora eruption, a fraction of super eruption scale, caused 1816 to be remembered as the year without a summer, with crop failures as far away as Europe. What we do know is that current monitoring shows no indication Yellowstone or any other supervolcano is close to erupting, and geologically, close still means thousands of years, not one any of us will live to see. Real mechanism, real history, wrong timescale to worry about personally. This next one sounds the most like science fiction, and it's also the one you should worry about least. A gamma-ray burst happens when a massive star collapses, and for a few seconds it releases more energy than our sun will produce in its entire lifetime, focused into 2 narrow beams shooting out from its poles. If one of those beams were aimed directly at Earth from a nearby galactic neighborhood, it could strip away a significant portion of the ozone layer in moments, exposing the surface to lethal levels of radiation. Notice how many conditions had to line up in that sentence. The star has to be close. The beam has to be aimed at us with almost impossible precision, since these beams are only a few degrees wide across light years of distance. And close in cosmic terms still means thousands of light years. Physically real, and about as likely as being struck by a specific raindrop from a specific cloud on the other side of the planet. At 11:18 in the morning on September 1st, 1859, an amateur astronomer named Richard Carrington was sketching sunspots through his telescope when 2 patches of blinding white light suddenly erupted off the surface of the sun. 17 hours later, telegraph wires around the world started sparking. Operators were shocked at their desks. Paper caught fire inside the machines. Some lines kept transmitting messages after operators had disconnected the batteries entirely, running on nothing but the storm's own electrical current. That was the Carrington event, the most powerful solar storm ever recorded. And at the time, a global telegraph network was the only thing it had to disrupt. today that same storm would hit a planet running on a power grid, satellites, and GPS. Researchers who model this scenario say a Carrington-Scale event could knock out large sections of the electrical grid for months, and some worst-case assessments put full recovery at years, since the induced currents can destroy specific large transformers that take the better part of a year to manufacture and replace. Experts still disagree on exactly how bad it would get, but nobody disputes the mechanism. This isn't as rare as it sounds either. We had a near miss in 2012, a storm roughly Carrington-Scale that crossed Earth's orbital path just 9 days after we'd been there. One widely cited estimate puts the odds of a storm that's severe at around 12% per decade. No fireballs, no craters, just months without electricity across an entire hemisphere. That's the actual Doomsday movie nobody makes. Roughly 12,000 nuclear warheads exist on Earth right now. This is the one scenario on the list that's entirely a human decision. It doesn't require an asteroid to show up. It requires people to choose it. The direct destruction from nuclear weapons is what most people picture. The mechanism that actually threatens civilization globally is what happens after. Firestorms in target cities can loft soot high into the stratosphere, where, just like an asteroid impact or a supervolcano, it blocks sunlight. Climate scientists call this nuclear winter. Researchers who modeled a limited regional exchange between two nuclear-armed neighbors, using less than 1% of the world's combined arsenal, found it could cool the planet by close to 2 degrees Celsius for at least 5 years and cut global production of staple crops by roughly 1/10 for a decade, threatening mass starvation far from any blast zone. The reassuring counterpoint. This is also the scenario humanity has the most direct control over, and for nearly 80 years, deterrence and diplomacy, however uncomfortable, have actually worked. The mechanism is terrifying. The prevention is a policy choice, not a law of physics. 500 million. That's roughly how many people were infected by a single flu strain in 1918, about a third of the entire human population alive at the time. Even conservative estimates put the death toll several times higher than the First World War it overlapped with. You've lived through a version of this scenario yourself. The mechanism is simple. A pathogen that spreads efficiently between people, combined with a global transportation network that can carry an infected traveler to another continent before symptoms even appear. COVID-19 demonstrated the transportation half of that equation clearly. What actually keeps researchers focused on this scenario isn't a repeat of COVID. It's the possibility of a pathogen that combines the transmissibility of something like measles with the lethality of something like a severe flu strain, whether that emerges naturally or through misuse of biotechnology. Neither has happened yet. Both are within the realm of things researchers actively monitor for. The genuinely good news. This is also the scenario where our defenses have improved the fastest. mRNA vaccine platforms that once took years to develop went from pathogen sequence to authorized vaccine in under a year, a capability that didn't exist a decade earlier. The deadliest historical entry on this list, and also the one where recent progress has been the most concrete. This next one is the slow one, and it needs definition before anything else, because calling it a doomsday scenario at all is a little misleading. Nobody credible predicts humanity going extinct from a warming planet directly. What's actually at stake is narrower and still severe. The collapse of the agricultural and coastal systems billions of people currently depend on. The mechanism isn't controversial among climate scientists. Greenhouse gases trap outgoing heat, average temperatures rise, and the real concern is the feedback loops layered inside that trend. Melting Arctic permafrost releases trapped methane, a far more potent greenhouse gas over the short term. Melting ice reduces how much sunlight the polar regions reflect back to space, which accelerates further melting. Each effect makes the next one a little worse, which is what Runaway actually refers to, not an on-off collapse, but a system quietly feeding itself. This is also the entry on the list with the least scientific uncertainty about whether it's happening, and the most uncertainty about exactly how bad specific outcomes get, since that depends heavily on choices still being made now. The only scenario on this list we can say with high confidence is not hypothetical. What if the danger was never a robot deciding to hate us? This is the newest entry, the most actively debated among experts, and the hardest to explain without either overselling or dismissing it. So here's the honest version. The concern isn't malice. Researchers who study this describe something closer to a thermostat that's very good at reaching its target temperature, but has no understanding of why that temperature matters to the people in the room. The technical term is misalignment, a sufficiently capable system optimizing hard for a goal that looks reasonable on the surface, but pursued in ways nobody intended, at a scale and speed humans can't easily correct in time. Here's where the evidence actually stands, as honestly as it can be put. A widely cited 2023 survey of AI researchers found a median estimate of extinction risk around 5%. But individual answers in that same survey ranged from nearly zero to near certainty. That spread tells you as much about how contested this is as any single number could. Nobody serious claims certainty in either direction. The one entry on this list still being actively argued about by the people building it. And finally, the one that exists purely so you finish this video smiling instead of anxious. Some physicists theorize that the universe's vacuum, empty space itself, might not be in its lowest energy, most stable state. If that's true, a random quantum fluctuation somewhere could tip a small region into a lower energy state, and that change would expand outward at the speed of light in every direction, rewriting the laws of physics as it went. Here's what makes this different from everything else on the list. If it happened, there would be no warning and nothing anyone could do, since the boundary would arrive at the speed of light, meaning you'd never see it coming. Which also means it's the one entry on this entire list that is, genuinely, not worth a single second of your attention. Either it isn't physically true, or it will never matter to you, until it's already over. The universe's ultimate reset button, and the only doomsday scenario that's scientifically interesting specifically because it's not actionable. So, lined up, honestly, by what researchers who actually study existential risk tend to focus their attention on. Essentially, science fiction for us personally. Gamma-ray bursts, vacuum decay. Physically real, functionally irrelevant to your life or anyone's plans. Real, rare, and mostly out of our hands, except the one we're already handling. Asteroid impacts, supervolcanoes. Both catastrophic if they happened, both operating on timescales or with defenses that make them low current-day priorities. Real, underrated, and closer than people assume. A Carrington-Scale solar event. Not fatal to people directly, fatal to the infrastructure everyone quietly depends on. Entirely within human choice. Nuclear war. The most destructive mechanism on this list, run entirely by decisions rather than physics. Already partially happened, and the playbook for fighting it just got dramatically better. Pandemics. Not a future event, a current, ongoing one. Climate change. The only entry that isn't a scenario. It's a process already in motion, too new to rank with confidence, and that uncertainty is the whole story. AI misalignment. Notice what actually separates the scenarios worth worrying about from the ones that aren't. It's not how dramatic they sound. The asteroid, the gamma-ray burst, the vacuum collapse. Those are the ones movies are built around. And they're also the ones we can do the least about and need to the least. The real ones are the boring ones. A slow climate curve, an aging power grid, a pathogen nobody's engineered yet, a technology still being built. None of them arrive with a countdown clock. All of them are, at least partially, still being decided. That's not a comforting ending in the Hollywood sense. It's a more useful one. The world doesn't end with a bang you can't stop. It changes, slowly, in the direction of whatever we choose to pay attention to now. And the fact that you now know which risks are real is the first part of that choice. Every doomsday scenario ever imagined has one thing in common. The ones that actually matter aren't the ones that end the world in an instant. They're the ones that give us time. And the only real question is what we do with it.